Okay, so pabawas ng pabawas. Kanina, 11 yata kayo or 12. Tapos naging 9 or 8 na lang yata ng part 2. And then ngayon, 7 na lang. Okay. So, it's only normal. Alright. So, are you guys still okay? Kaya pa ba?
Kaya pa po.
Kaya pa. Okay.
Kaya pa.
So, don't you guys worry. Okay. So, I just really think, okay, in my own way of thinking. Okay. So, when it comes to finals, Thevenin's theorem and then Norton's theorem is the super, uh, well, depende kasi. Like, for example, if you guys are going to take a look on this one, yes, applying the concept of Thevenin's theorem and then Norton's theorem is super easy. However, on how you simplify things or how you analyze things. Okay, like for example, parallel ba ito? Okay, magko-combine ba sila? Okay, ano ba yung magiging parang circuit ko na kapag katapos kong makombine, etc. etc. Okay, so baka dun kasi nagkakamali pala. So that is why uh, fundamentals is very important. Okay, so solve a lot of parallel circuit, learn how to simplify them properly. Okay, because in my case, hindi ko siya matuturo talaga. Ayun na mismo yung parang makaka-realize. Okay, so sinasabi ko lang na siguro the simplest way is if this one is a node, okay, and then it has another components in here, then this one is already in parallel connection. Okay, but if there is no other, if this is not a node, and then there is no other components on that node, then that is a series connection. Okay, so I think yun na yung pinaka-clue nyo kung sa tingin nyo series ba sila or parallel ba. Okay, baka doon pa lang kasi medyo madadali na kayo. Oops. Okay, so dapat practice lang, okay, when it comes to simplifying things on Thevenin's theorem or Norton's theorem. Okay, so yes, it's easy, but it needs a lot of practice for you to be able to master and how to simplify this kind of circuit. Okay, anyway, going back to our topic with Norton's theorem. Okay, so again, this one has the same uh, concept wherein you can simplify any linear circuit into a super simplified version, okay, as long as it doesn't have exponents or roots. Okay, so let's use the same example. Okay, so we have 28 for the R load and then 7 and then 1 right here, but our goal now is of course converting this one into a Norton equivalent circuit. So before we have a series connection. Okay, we have a series connection, E Thevenin, R Thevenin, and then R load. But on the Norton's theorem, okay, we now have a parallel connection. Okay, we have the I Norton right here, which is your current source, and then the R Norton, which is your computed resistance. Okay, and then the R load is still the same. Okay. Okay, so no important thing to mention. So yeah, just remember that this is the Norton's equivalent circuit. So with that, let's be so I'll leave the reading part to you guys. So I already discussed what is the I Norton and then R Norton, which is this one RN and then IN, and the same concept of course. So you have to remove the load resistor, and then after that you can remove your voltage sources. So if it's a voltage source, just simply short it, and then you can now find the total resistance or the uh, ano bang tawag dito? RN, okay, Norton's resistance. Okay? So, the same concept, okay, apply this one, okay, you will have this R1 and R3, and then they are now in parallel connection since we have node A and node B right here. And then the one that you will get is, of course, a 0.8 ohms. Okay? So, after solving the uh, Rn, okay, lagi ko na lang nakakalimutan. So, Rn is the Norton's resistance. Then you can now find the Norton current. Okay, so I would say that Norton current or Norton current source is a lot easier to solve than the VTH or the Thevenin's voltage source. Why? Because just simply Ohm's law, apply Ohm's law on this one, and then Ohm's law on this one, and then you can now find the current that is flowing in here, and then the current that is flowing in here, and then you can just simply add them, and then you now have the Norton's current. Okay, so in what way? So if you guys are going to take a look on this one, okay, so we have a current that is flowing from here to there, from here to there, and then just by applying Ohm's law, okay, I is equal to B divided by R. So let's apply this one on the left side first. Okay, so I is of course unknown, but V is 20 volts, and then R is 4 ohms. So with that, 20 divided by 4 is 7 ampere, or 7 amps. So with that, we already know that we have a current that is, a 7 amp that is flowing on the left side. So on the right side, same, I is equal to V divided by R. I is equal to 7 divided by 1. So 7 divided by 1 is 7 amps also. Okay. And then with that, let's just see that we're going to apply KCL, okay, on this node A. And let's say this is our node B. Okay, so KCL at node A, okay, is equal to, let's say, we need, say, I1, and then this is our I3, and then this is our I2. Okay, so again, going in to a node is positive, and then going out to a certain node is negative. Okay, just remember that one when it comes to KCL. And then from here, as you guys can see, we have I1 going in, and then I3, which is also going in. So I plus I2 minus I2 is equal to 0. And then from here, the one that we are looking for is the I2, since that is the unknown. Okay, so I2 is equal to I1 plus I3. Okay, I2 is unknown. I1 is 7 amps, right here, the left side area. And then I3 is 7 amps also, which is the one that is on the right side. So I2 is 14. Okay, so there you go. Oops, sorry. So that is why we have this 14 amps right here, which is this one. Okay, so our RTH, I mean RN, bakit laging RTH? Rn is 0.8 ohms, and then In, Norton's current, is equal to 14 amps. So once you have those two variables, then you can now perform this kind of equivalence circuit. So just replace uh, the given values. So something complete. Okay, let me use this one as our complete circuit. Okay, so 0.8 for the R Norton, and then 14 amps for the I Norton. So were you guys able to follow?
Yes, sir.
Okay, so super easy with the use of Ohm's law. Okay, well, that depends on the circuit. Okay, so in here we can just simply apply Ohm's law, since we can easily identify the current on the left side, the same with the right side, and then just simply combine them, and you will have 14 amps. Okay, after that, you will now have this given values right here. So of course, you can now find the voltage drop across R load, voltage drop across R Norton. Okay, to do that one, we have to solve, what can we solve right here? So course, we can solve the R total. R total is equal to R Norton, Rn in parallel with R load. So let me just copy and paste this one. So Rn, let's have a different equation since hindi natin ma-replace yan, of course. So Rn times RL divided by Rn plus RL. Okay, let me copy this one again. So just apply the rule of parallel connection for solving the resistance. Rn is 0.8, and then RL is 2, 0.8, 0.8, and then RL is 2. And then from here, we can now solve that this one is 1.6. Tama ba? 0.8, yeah, 1.6. And then 2.8. And then our total is equal to 1.6 divided by 2.8 is equal to 1.6 divided by 2.8 is 0.57. Okay, please check. Maybe I have a different answer. 0.57 ohms. Okay, so after having the R total, we can now find the V total. V total is equal to I total. IT na lang para mas malit. I total times the R total. I total is equal to 14 amps, which is our I Norton, times R total, which is 0.57 ohms. V total $7.98. So please verify also my answer. Okay, baka may mali. So we can recheck that one. So 7.98 volts. So okay, naalala ko na. Okay. So this one was actually rounded. Okay. Because if you guys are going to take a look on this one, ang total voltage natin is 8 volts. So for consistency, let's just round this 7.98 into 8 volts. Okay? Para lang magkapares yung nasa table natin. Okay? Then since they are in parallel, so the voltage across R Norton is of course 8 volts also. So ilagay ko na lang dito para mas madaling basahin. And the same, okay, our voltage across RL is also 8 volts. Okay, and the next one is maybe you would like to find the current across R Norton and then the current across R load. So that's also possible, of course. So IRN, okay, IR Norton is equal to the voltage, okay, across RN, IB divided by the R Norton, which is RN. Yeah. So IRN, so VRN or VR Norton is 8 volts divided by RN, which is 0.8. So this will give us a value of 10 amps. Okay, and then solving for the IRL, okay, the current across this load resistance is so 8 pa rin kasi isa lang naman yung voltage voltage across natin if we have a parallel connection. So VRL is 8 volts and then RL. Okay, so for consistency, let me copy this one. VRL divided by RL. And 8 volts and then RL is 2 ohms. So 8 divided by 2 is 4 amps. Okay. So to check kung tama ba yung current natin. So of course, some current will flow in here and then some current will flow on the R load. So I total, which is equal to our I Norton. So that's IRN. Oops. My bad. IRL to. And then IRL din to. May nabura yata ako ah. Ano ba? Parang may kulang. Okay, this is for the IRN. And then IRL. May nabura nga ako. Okay. Wait a second. IRN. And then VRN. And then RN. Okay. So there you go. So I total is equal to IRN plus IR. So that IRN is 10 amps and then IRL is 4 amps. Wherein it is correct. Yung nga lang para consistent tayo. 14 amps. So there you go. We now have the voltage drops or voltage across, which is 8 volts. And then the current across R Norton, okay, is 10 amps. And then the current across R load is 4 amps. Okay, so I hope you guys were able to follow. So let's check if we have the same result. Is it right here? So for the voltages, of course, we have 888 since they are in parallel. And then for the current, so we have 10 amps for the IRN. And then IRL is 4 amps, which is correct. And then the total current is 14 amps. And then for the resistances, so we have 0.8 right here for the R Norton, and then 2 ohms for the R load. And then we have here 571.43 milliamps. So this one is the same with 0.57 ohms. So for you to be able, baka hanggang ngayon, may nalilito pa rin sa milliamps saka amps ha. Milliamps saka milliohms, okay? Not amps, because this one is a resistance. So in here, if you want to have the, oops, mali. If you want to have the milliohms, okay, milliohms value, milliohms value, just multiply this ohms value to 1000. Okay, so in here we have 0.57. Just multiply that one to 1000, and then you will get 570. Okay, 570 na lang kasi wala na tayo ng mga ibang values like 1, 4, and 3 since I did only get the 2 decimals of this one. Pero kung tutuusin, ito yung exact value niya, 571.43 milliamps. Milliohms rather, not milliamps. Medyo unusual kasi yung milliohms, okay, na unit pagdating sa saan ko ba ilalagay ito para kita nyo. Anyway, so ganyan na lang. Ibaba ko na lang. There you go. So this one has a value of 570 milliamps. Okay. Which is the same with this one. Okay. So were you guys able to follow?
Yes, sir.
Okay, so I hope we're clear with Thevenin's theorem and then the Norton's theorem. Okay, anyway, so more explanation. So again, I will leave the reading part to you guys. And then here's a review. Okay, so kind of the same, removing the load resistors and then removing all the power sources. So just short it if it's a voltage source, just leave it open if it's a current source. And then what else? And then from there you can now find the Norton's current and then the Norton's resistance to transform that one into a Norton equivalent circuit. Okay, so we have here another example. So let's have this one real quick. So we have 10 volts, 20 volts, 10, 20, and then 40 ohms. So the same concept, just remove this one. Let's say this is our R load. So remove the sender for the ohm load resistor. So this is our R load. It's just that it wasn't able to put here this one as our RL, but this is our RL, the 40 ohm load resistor. Okay, so just short it. Okay, and then what else? Teka lang. Short out the terminals. Wait a second. What did we do in here? Ano bang hinahanap muna dito? Just remove the power sources. The arrow notation by the source direction connection to calculate the Norton resistance. We do the exact the same thing as with Python. Yeah. Okay, so same naman. So, yeah, I think it just wasn't shown in here. But you have to remove this one for you to be able to solve for the uh, Norton's resistance. Okay, so I did verify that one in here. So to calculate the Norton resistance or the R Norton, we do the exact the same thing as we did for calculating Thevenin resistance. So yeah, we have to leave this open and then combine those two, and then you will get 0.8 ohms using a parallel connection in here, R1 parallel to R3. So the same concept with what we have in here. After leaving this one open, okay, and then after removing the sources, okay, just short this one, okay. Hindi lang pinakita kasi solution na kaagad yun dito. But yeah, just short this voltage source right here. And then you can now combine this 10 ohms and then 20 ohms, okay, via parallel. So where is the computation for the R Norton? Kasi current to eh. Inuna niya yung current. Okay. Kaya pala medyo confusing. Okay? So, nag-start kasi siya sa pag-solve ng current. Okay? The Norton's current. So, of course, the thing that you need to do is, of course, short is one. Okay? Just like what we did in here. Okay? So, iso-short lang din natin to for us to be able to find the current on the left side and then the current on the right side. So, let's solve first the IN, okay, or the Norton's current para masundan natin to. So, for the I1, of course, ohms law lang, okay. So, I is equal to V divided by R. So, left side, 10 divided by 10 is 1 amp. So, the same with the right side, 20 divided by 20 is 1 amp. So, as you guys can see, we have the same flow of current that will merge on this node AB, okay, or this spot right here. So, of course, I1 plus I2 is now equal to our IN, okay, or I short circuit. Actually, IS naman yung tawag nila dito. Okay, IN is also equal with IS. Okay, that's the other different terminologies for that one. So in here, we also call this one as RS. Okay, so the same siya dito. Okay, then after that, we can now find the Norton's resistance. So remove the resistance right here, and then short the voltage sources, and then combine those two via parallel. So R1 times R2 divided by R1 plus R2, 20 times 10, and then 20 plus 10. So it will give you a value of 6.67 ohms. So with that, you now have the values for your IS or I Norton, and then RS or the R Norton. And then you can just simply put here the RL later on, which is this one. And then from here, you can now solve for the total resistance, and then you can now solve for the voltage across this RL or the VAB. Okay. So since it's already in here, and I think Meron na lang tayong 12 minutes. Okay, so enough pa naman yung oras natin. But I will leave the computation part to you guys since it's just a matter of, verifying whether this one is correct or no. Okay, just simply follow the given uh, equations right here or the solution. So with that, you can now find the total current across your entire circuit. So just do take note that this IS right here is not our total current. Okay. Uh, Pag isosolve natin yung, teka lang, may bad. I think yun na yun. Okay. So, nire-retrieve ko yung sinabi ko. This is already our total current. Okay. So, yung meron tayo dito, okay, is the current across RL. So, may bad on that one. Okay. Which is 0.286 amps. And then, of course, some current will flow in here. Okay. The remaining current. And then more examples. Okay, so again, we have here the English video example, and then one Tagalog video example, which is the same with this one. So siya rin yung, sa kanya rin nang galing, ito kay Engineered Math. Okay, sa kanya din galing example for this Tagalog video example. Okay, and then here are the summary. Okay, so again, the first thing that you guys need to do is find where is RL and then remove that one, and then you can now start solving for the RS and then the IS. Okay, so either of those two, you can interchange step 2 and step number 3. And then from there, you can now find, or you can now transform this one into a Norton's equivalent circuit, and then start finding the current across RL and then the voltage across RL. Okay. And then here is the reference for this topic right here. This one came from circuitglobe.com. My bad. Okay. Bakit ang gulo ko dito? So, ginawa ko pa kasi to last year, I guess. So, this one is just another info. Okay. But the source of this module, this one came from all about circuits. Okay. And then some, okay, came from electronics tutorials. Okay, and then some of my ideas came from this YouTube video. Okay, and that's already it for the Thevenin's theorem and then the Norton's theorem. Okay, so time check, we still have 9 minutes and 17 seconds. So we still have plenty of time. So if you guys have a question, so feel free to ask me now. Or ako na lang magtanong. So were you guys able to follow so far the concept of the Thevenin's and Norton's theorem?
Yes, sir. Yes po.
Okay. So now that you guys have learned the basics, so please enhance more your your analyzing analysis, okay, analysis skill, okay, on how to analyze complicated circuits. So dito nyo malalaman kung talagang tama ba yung sagot nyo o hindi. Okay. So dito sa mga links na ito. Okay, just try to visit these links right here. So we'll ask you some basic questions. Okay, and then it will also show you the solution, of course, at the same time. So practice lang. Okay, so just do take note that having two examples in one theorem is not enough, especially that that is your first time hearing about the theorem. Of course, I will teach to you, or most of the websites here in the internet will only teach you the super basic. So please explore more in answering complicated circuits. So you can find a lot of articles discussing about complicated circuits. Okay? So pwede nyo din siyang i-verify using other theorem. So that's the perk of having a lot of theorems, since you can verify whether your answer is really correct or no. Okay? And don't forget, hindi ko pa yata na-publish. Okay, let me just preload this one. Don't forget that you're going to have a quiz on Thevenin's quiz for this module. Okay, module 7 and 8, and then the same with the Norton. The due date is June 29. Again, you guys have exactly 10 days for this one. The same with the case study number 4. Okay, so yeah, I think that's it. Those are the only things that I need to mention. So anyone who has a question or clarification so far? Or if none, then that's already it. So again, just give me a thumbs up and then you guys be no go if you don't have a question anymore. Okay, all right. Okay, okay. So thank you guys for coming. Okay, I really appreciate it. So goodbye and see you guys next meeting.
Bye, sir.
Goodbye. Goodbye. Question? Oops.